So, in continuation of microservices architecture series, an important concept which one really needs to have a good handle on is patterns. Now, patterns typically came from building and construction industry. It was Christopher Alexander, a real-world architect, who probably figured out that a lot of buildings which eventually get built or bridges which get built, there's a lot of stuff which is reusable across, each of the architecture, and trying to go ahead and give it a more formal definition is what came up with the pattern idea, the concept of a pattern and pattern language. Now, when we look at the software world, there are a lot of software architectures which have a lot of similar components or reusable components across architectures. So pattern essentially is a reusable solution to a problem that occurs for a particular context and idea which has its origins in the real world architecture that has been proved useful in software architecture and design. Now, when we actually kind of get into a little bit details on the design patterns, which is specifically dealing with software design, the gang of four patterns. Okay, typically from creational, structural, behavioral. I mean, obviously, there's a very in-depth discussion and a training session which is required to kind of come up with the understanding of gang of four pattern. But it would be good to understand the different creational patterns when we actually go about creating software design, as well as how components within the software design are structured, and similarly, and how do they behave in the real world. So basically, it's all in around kind of design from a software design standpoint of view, in terms of how software really kind of are built and run within an execution environment. Now, let's take a recap on pattern, and let's take it from an example standpoint of view. Now, you're building a banking application that must support a variety of overdraft policies. Now, each policy defines limits on balance of an account and fees charged of an overdrawn account. Now, typically, the client application need not know. Now, based on the balance, you may end up choosing an overdraft A, overdraft B, and overdraft C. Now, typically, this is what we call as a strategy pattern, where the decision making in terms of which overdraft has to be applied is not the part of the client. And so, strategy pattern is intended to provide a means to define a family of algorithms that encapsulate each one as an object and makes it interchangeable. The strategy patterns lets the algorithm vary independently from a client that uses it. So effectively, there's a strong amount of decoupling between the client and the implementation. So this gives me the flexibility at a later date if I want to add one more overdraft D. It's a lot more easier from a design standpoint. So this is kind of addressing some of the design, software design elements, which are required, or some from a strategy standpoint of view. It is basically trying to decouple the client from its actual implementation of the overdraft policy. So as you see, patterns describe a context which can be applied. A pattern structure includes forces to be addressed when solving a problem in a given context, resulting context, and related patterns. Now, when it comes to microservices, now microservices pattern language. So, pattern language is essentially a collection of all the patterns. So, when we refer microservices, what are the different patterns which are applicable? What so basically it's ultimately the pattern language is nothing different. It's just a collection of all the patterns that are related through the through these relationships, what is we call as pattern language. And patterns in a pattern language work together to solve problems in a particular domain. Microservices pattern language is a collection of patterns that help an architect and help architect an application using microservice architecture. So essentially, it's trying to basically, if I look at a microservice pattern language, the patterns come along with it. It's kind of going to help me in terms of to decide, should I really go microservices or not? Is it really? Is my scenario really is a good fit from a microservice standpoint of view, or should I just kind of walk away from this? So pattern language helps you decide whether to use microservice architecture. Now, since it's in conjunction with monolithic application, or it describes the monolithic architecture and the microservice architecture, along with the benefits and drawback, because that's an eventual transition from A to B. Now, if microservice architecture is a good fit, the pattern language will help in use it effectively by solving various architecture and design problems. Now, this is what the microservice architecture pattern language look like. Now, obviously, on the left hand side, we've given the elements in terms of the predecessor, successor, alternatives would be, and generic and specific. This is the standards of pattern language, which I will not be covering. So, typically, if I'm looking at the microservice architecture pattern, it's been broken down into application patterns, application infrastructure patterns. Now, if you look at the application patterns, decomposition, which is a session which we'll cover separately, database architecture, querying, maintaining data consistency, and testing. Application infrastructure is related to cross-cutting concerns, security, and basically it takes it further from an observability standpoint, which spans across the two. Transactional messaging, communication style, reliability, and eventually we get into core infrastructure pattern, which is nothing but deployment, discovery, and external API. So I think so. This gives me a very clear picture in terms of what are the different architecture patterns. What are the different patterns which are applicable from a microservices standpoint of view, and this kind of gives me the holistic picture. Now, types of patterns involved in the microservice architecture. Infrastructure pattern solves problems mostly with infrastructure issues outside of development. Application infrastructure pattern, infrastructure issues that also impact development. Application pattern solves problems faced by developers. Now, typically patterns from a decomposing an application standpoint of view. Now, this is a session which we have to kind of dig deep and look at decomposed by business functionality or decomposed by subdomain. Now, the some of the other patterns which we will come across when we deal in the microservices: communication pattern, data consistency pattern, patterns for querying data, service deployment pattern, observability pattern, patterns for automated testing, patterns to address cross-cutting concerns, and security patterns. That's it from a pattern language standpoint of view, and we will continue with the remaining sessions in terms of decomposition, and that's going to be the next area. Thank you.